Welcome to another Aspire demonstration video. In this video, we'll look at the anti-cloning protection that was contributed to the project by Nagravision. So what are the security requirements? Well, in this case, we want to prevent that multiple clones of some functionality can run in parallel. In practice, mobile apps embed personal keys, and we want to ensure that a personal key can only be used in one instance of the software. It's okay if that scheme still allows attackers to run a single or even a couple of clones in a lab. That's okay because it will have very little, if any, impact on the income of the content or service provider. However, wide-scale cloning should not be possible. So if a successful attack is developed within a lab, the cost of scaling it up to widespread use should be really high, and furthermore, the chance for remaining undetected in that case should be low. So here we have a picture explaining how it works. At the top on the right, you have the original application. At some point in the application, the anti-cloning manager is invoked. This manager accesses a file on some file system that persistently stores a tag. The manager updates the tag and writes back the new tag value. It also sends the tag to a server, and there the server can check whether or not the tag had the expected value. The server-side logic also updates the tag and stores the new value and sends back the response to the anti-cloning manager. If the server here was expecting another value than the one that the manager sent, the response of the server will instruct the manager to invoke a reaction, for example, to quit the application or to corrupt some data or to degrade gracefully. Also, this logic can in fact, if the application is an online application, it could also communicate to an application server to stop providing services or content. How does this prevent wide-scale copying? Well, the problem is that multiple applications in that case will work on the same tag, and when multiple of these applications run in parallel, they will all send the same values to the server, which will detect this. So now let's have a look at how this works in practice. So here we see an example program. We see two Aspire annotation. One marks the point where the tags are updated and sent to the server. The second one marks the point where the decision is taken whether or not the responses from the server indicate that this is not a cloned version. The annotations will be rewritten to code that invokes the anti-cloning mechanism and that updates the status flag, and then later in the code the status flag is checked, and in this case we'll just print whether or not cloning was detected. Now we see three terminals here. On the left you have the server window. On the top right you see one of our embedded boards. We have a binary there, and if we execute it, you'll see it starts invoking the server. So you see in the server log that multiple calls and updates for the tag are requested. On the client side you see that we did 50 calls. If you execute the program again, you see this number is randomized. In this case it's 36 calls. You also see that a file was created, the anticloning.bin file, and this is the file that persistently stores the tag. Now we're going to copy those files to another board. On the other board you see there is no file. You see that after copying there is a file. And if we run that file, you'll see that the server again receives requests, and you see that this program works pretty well. And so we have kind of fair use. As long as only one copy is executing, the tag value remains what is to be expected, so this works correctly. However, if we run the original one, we see that an error message was received, and we see that on the server side the clone was detected. That's it. Bye.